Howdy, students. In the last video, we talked about the carbon budget and how much carbon dioxide we can emit and stay below the warming levels the world has judged as being dangerous. We saw there that humans can emit 580 gigatons of carbon dioxide to the atmosphere to have a reasonable chance of staying below the 1.5 degree threshold. This plot shows the emissions per year required to reach that 1.5 degree budget. We are here, so we need to start rapidly reducing emissions immediately. Emissions need to decline 45% below 2010 levels by 2030. After these initial deep cuts, emissions need to reach net zero by 2050. And after that, emissions need to go negative. Negative emissions mean that humans are removing more carbon dioxide from the atmosphere than they're adding. Our ability to do this at this scale is entirely speculative. This scenario requires at least 100 billion tons pulled from the atmosphere over a few decades. This is a Herculean industrial task, to put it mildly. If you think about how much infrastructure and money it takes for us to emit carbon to the atmosphere, wells, mines, trains full of coal, pipelines, refineries, trucks, power plants, it seems likely that it's going to take a comparable amount of infrastructure to pull carbon out of the atmosphere. This will be difficult, but if we can do it, then we can keep the warming below 1.5 degrees. But we have another option. We can let the temperature exceed the 1.5 degree limit for a few decades. This temporary excess in temperature is known as an overshoot. We talked about it in chapter 11. If we look at the emissions trajectory associated with this overshooting 1.5 degree limit, we see that it has slower near-term cuts. This reduces the cost of achieving the policy goal. To understand why, imagine you build a coal-fired power plant. This is a huge upfront cost that pays for itself over many years. If it takes 30 years to pay for itself, then it is only a profitable endeavor if the plant operates for much longer than that. If you tear the plant down after, say, 25 years, then you lose money. So the cheapest way to achieve any emissions reduction is to let infrastructure wear out naturally. And when you replace it with climate-safe technology. By pushing emissions cuts further into the future, you can wait until the coal-fired power plant has reached the end of its life and then replace it with solar or wind energy. This is the cheapest way to cut emissions. So this overshoot emissions trajectory with slower near-term cuts allows more equipment to be replaced on schedule instead of scrapped prematurely. This minimizes near-term costs, but there's a flip side. Remember from the last video that we have a set carbon budget that we cannot exceed. More emissions in the near term means we have to have bigger carbon removal in the second half of the century. The scale of the problem is even more daunting than the scenario with no overshoot. We'll need to remove hundreds of billions of tons of carbon in just a few decades. We talked about carbon dioxide removal in chapter 11, so you might want to review that if you've forgotten about it. There are several approaches to do this, but whatever approach is chosen, the technology must be cheap and scalable, meaning that you can build enough of it that it can remove billions of tons of carbon every year. It also has to have acceptable side effects. So what's the upshot? Stabilizing at 1.5 degrees is going to be really, really hard, even if we allow overshoots. Remember that we've already warmed the planet 1.1 degrees Celsius. So the 1.5 degree target means we have to stop warming almost immediately. This will require deep near-term cuts, beginning immediately, and large amounts of carbon to be removed from the atmosphere later in this century. In addition, as you saw in chapter 6, other greenhouse gases make important contributions to climate change. Reducing emissions of non-carbon dioxide greenhouse gases like methane will also be required to meet a 1.5 degree Celsius target. Most importantly, however, is that meeting this goal requires political will. Looking around the world right now, it's hard to be optimistic we'll start deep cuts in emissions soon enough to stabilize at 1.5 degrees. Now let's talk briefly about the 2 degree target. This shows a trajectory for 2 degrees, along with the 1.5 degree trajectory with no overshoot. Because of the larger carbon budget, the rate of emissions reduction is quite a bit slower for 2 degrees than it is for 1.5 degrees. Nevertheless, we still need to start cutting emissions in the very near future. In this 2 degrees scenario, emissions reach zero late in the 21st century, and then there are small negative emissions thereafter. Note, though, that other trajectories are possible. Like we did with a 1.5 degree target, we could trade off less aggressive early cuts for larger cuts later in the century. Thus, stabilizing at 2 degrees is easier than the 1.5 degree target, but it is still going to be a challenge. The higher temperature target also means that we will experience larger and more costly climate impacts. Whatever target we decide to aim for, there's a trade-off between strong action now and strong action later. If near-term cuts are weak, then we'll need larger carbon removal later in the century to stay below either target. It's amazing to realize that we've known about this problem for many decades. Had we taken action on this in the 1990s, when the details of the problem were crystal clear, the effort required to reach one of these targets would have been much, much less than required today. But we didn't, and now it's the metaphorical night before the exam, and we have to do a semester's worth of studying in a few hours. If we keep dithering for a decade or two, we may lose the opportunity to achieve either of these targets and commit ourselves to much larger, more costly, and more painful climate change. And now, your moment of dog.